Good morning, everyone. How are we all doing? Having an excellent NDC Copenhagen? There's some nods. That's good. Good signs. Excellent. Thank you so much for coming along to see me and what I've got to talk about this morning. I know there's a lot of choice out there, a lot of excellent speakers, so I very much appreciate you being sat in this room today. My name is Nash. I am a developer relations engineer at IBM, tiny little company, do a couple of things. I mostly work at IBM on a bunch of our open source stuff in the world of AI. So currently a lot of focus on a tool called OpenRAG, which is a sort of open stack for building customizable RAG applications for your agents, as well as Docling, which is part of OpenRAG, but also is a document processor. It's particularly good at scooping all the text out of PDFs and things like that. PDFs are a nightmare. They should all burn in a fire. But if we can't burn PDFs in a fire, we should put them through Docling instead and just get the actual text out. If you want to find me online, I'm Phil Nash, kind of everywhere. Please do connect. And if you ever have any questions or want to follow up with anything about this, I'm always happy to connect and chat. It's 2026. Agents are here. Is anybody using like an agent on a day-to-day basis in their work? Of course, we're coding agents, presumably. Anybody kind of using like a more personal, like just organize your life kind of agent? Less people. Cool. I'm lightly on the fence about like how much of my life to give over to automation and things like that right now. It's a little bit it's a bit concerning. I genuinely, over the weekend, built myself like an email inbox for an agent that only ever lets it draft an email. Because giving it access to send things on my behalf, terrifying. But giving it access to like think about it and give me an option, I'm okay with that. Agents are here, and we're working out like how to use and how to live with them. But what I wanted to approach in this talk, why we're going to build an AI agent, is actually just kind of seeing how they work under the hood. I want to help kind of demystify what's actually happening when we interact with an agent. And we're going to do so by building one up from scratch. But to kind of to think about that beforehand, like what is an agent? Like, there's been a bunch of kind of definitions of agents over time. We kind of now know because we're using them on a daily basis. But a few people have said various things. There was a paper from Google in sort of late 2024. It was like October-ish 2024 that said a generative AI agent can be defined as an application that attempts to achieve a goal by observing the world and acting upon it using the tools that it has at its disposal. And this is pretty accurate. An agent like observes the world or its perception of the world and tries to act upon it with tools. That was a paper from Google. At the start of 2025, Jensen Huang, CEO of NVIDIA, said that an agent has AIs that can perceive, reason, plan, and act. And those are effectively the same things, just that's less words. I appreciate that. Although, when it actually comes down to it, the sort of nuts and bolts, the actual under-the-hood kind of definition, I think, comes from, was eventually sort of written down by Simon Willison, who writes a lot about this kind of stuff, and just it kind of boiled it down to it's an LLM agent, runs tools in a loop to achieve a goal. And we're going to see how that works, but it's fairly simple. In fact, this actually kind of takes out the perception kind of layer that the other two quotes kind of include. It runs tools in a loop to achieve a goal. It can actually, it only gets to perceive what we give it access to. And once it does that, it attempts to achieve its goal just by running things in a loop. That's it. It's a big while loop at the bottom of all of this. Tools on the other hand, back to the original Google paper on this, tools bridge the gap between the agent's internal capabilities and the external world. And this is kind of the important part here. What we've been given is a large language model that has the capability of generating text. And that's very cool, but generating text doesn't have an impact on anything in the world apart from the person reading it. And most generative AI text doesn't really have an impact on people either. But when we give it the access to impact the world using functions or tools, that's where we can actually get them to change something, right? And it's kind of important to note that agents, when they are running tools and they're doing stuff like that, they're still just generating text. And actually the the capability, the importance of actually running code to impact the external world is up to us, is up to our programs, up to our harness for the agent or for the model to run within. So it ends up looking a little bit like this. This is a diagram from that, again, from that Google paper. They had it right in 2024. It's pretty impressive. An agent runtime, or actually they are more likely to be called harnesses these days, kind of includes the model. That's pretty core to the whole thing. But then it includes a bunch of the orchestration. This is the code that you put around the model, and that's what we're going to kind of build through today to orchestrate what it does. So give it instructions, give it a system instruction, and line it up with chat messages. Handle some memory in there. We're not going to go for very complex memory today, just with short-term kind of stuff, but you can deal with long-term memory as well. And then the model has to kind of have that reasoning planning. So that's somewhat part of the instructions, but it kind of works there. And then you just add on the tools. Just plug those in and let it go. And then, yeah, the rest is a loop between the user saying stuff and the agent coming back to you. So let's build something. Yes. What I'm going to do is drop out of there, and I've got over here, this is a JavaScript application. It's not very complicated. What I have at the top is like the actual code that's running the stuff, and at the bottom there is a chatbot running as a CLI, effectively. Currently, it's a really bad chatbot because all it does is echo things back to you. This is worse than Eliza that Richard brought up in yesterday morning's keynote. It just echoes things. Not very useful at all. The rest of the kind of harness right now is just creating the CLI. It allows me to use some history, so I can press up and not type quite as much. And yeah, the agent does this. It's not very good. So let's change that. I'm going to start by creating some basic generation. Basic generation, that's what the slide says. Let's start. I'm going to copy my echo agent and build from it. So this one will be basic agent. And in this, all we're going to do is hook it up to an LLM and actually start that process of generating real actual text. To do so, I have a couple of little helpers, merge options and gen AI from utils AI.js. These aren't very complicated things. Merge options basically does give me a bunch of defaults for the agent. And so in this particular case, the agent we're going to be, or the model we're going to be using, is Gemini 3 Flash Preview. I realize Gemini 3.5 Flash is out now, but this one works. In fact, I've done this talk with Gemini 2 Flash. Like you don't need a very good model for this to actually work. We've got a little bit of config. These are just the various sampling kind of configs for the models. I think Google kind of recommends these as the basic kind of a temperature of 0.2, a top P of 0.95, and a top K of 30 to kind of give decent starting results from a model. And those are just really controlling like how creative it's going to be. And then my system instructions are going to be your helpful assistant, very basic. And then the rest of it, the other thing is we've got the Gen AI helper, which is just hooked up to Google Gen AI, so using the API key. Cool. So in my agent class, I'm going to create myself a constructor, which has some options. And all we're going to do is, oops, hello. Copilot is going to get in my way today, isn't it? We're going to merge the options that we pass in with those defaults. And instead of returning echo prompt, which is useless, we'll make a response. That's not how that works. It's genai.models .generate content. And I'll note that I am using Google and Gemini for this, and I'm using that the Google SDK for this, but really all of the major models work the same way for this. You could do this with any of them. I have done this using OpenAI before, and that's fine. So we're just going to generate using the prompt that's come in, and we'll pass in the options and return the text. Cool. So if I go back into my index here and change echo agent to basic agent, that's going to restart my thing there, and if I say hello this time, it breaks immediately. Cool. It's not contents, it's contents. Hello. There you go. You miss an S or you add an S and everything goes wrong. Hello, how can I help you today? We now have you're helpful. We now have a helpful assistant, but not a very good one. Still, we haven't got very far because this is where I like to introduce myself to my assistant. I'm like, hi, my name's Phil. And it's like, hi, Phil, it's nice to meet you. And then I'm like, all right, cool. What is my name? And it's like, immediate amnesia. I don't know your name yet, I'm an AI. Because what we've done there is we've just got text generation. That's all we've got here. We are not giving it any memory of any sort. And so I think if I do that, it has no memory, it has no tools, it has no capability to achieve anything in the external world. All it can do is generate some text, and then it's immediately forgotten that text it's generated, and it starts again every time we go to it. So let's turn it into a chat and actually give it a little bit of memory. We're going to move quickly through this bit. So our basic agent, not very good. Let's make a new one. Copy, paste. This one's going to be the chat agent. And the secret behind chat and the basic kind of short-term memory is that in this early version, we just generated content using just the incoming prompt each time. And to do chat, you just pass all the previous messages to it as well. That's why it gets more expensive over time as you build up a chat with a model, because all you're doing is passing in all the previous messages. And if you've ever hit that like compaction when you're doing you're coding with an agent, that's because you've run out of space, and it actually has to affect its memory at that point. And so Google does make this a little easier with their SDK. We can create a chat using the options, and this is just it's just a useful little thing that is going to handle the messages for me, because that's easier. So instead of calling generate content each time, we're going to call this.chat.sendMessage, and it's not contents, it's message, and the options were handled already. So that this chat, every time you send a message and every time you get a message back from the model, all it's doing is putting that into an array of messages and then sending them all again the next time. And so when we do that, I can change up to my chat agent and see if it's still working. Hello, yes, all right, my name is Phil. It's nice to meet you, Phil. That's cool. What is my name? Your name's Phil. So now we have memory. Good. So it knows what it's done over time. Because that's useful, like, particularly as we get to calling tools and things, knowing what it's managed to achieve so far in pursuit of its goal is important in order to understand whether it has met that or whether there's more stuff to do. We see this as chat now, but it is important for all of that stuff as well. The next thing I then like to ask it is, what is the date today? Any guesses as to what the date it thinks it is? What do you reckon? April 2024. Actually, I think that's not too far off. I think it's going to be May. Yeah, May 22, 2024, which I assume is something to do with whatever the cutoff date is. But it's very confidently wrong about this, and I like that, because I can say, no, it isn't, and we'll see what it says. Probably, you're absolutely right. I apologize for the confusion. Oh no, I was talking to it earlier, and it changed its mind to July. It definitely. I mean, to be fair, time zones is a potential thing. Isn't May or 2024? Try again. See what we can get out of it. Thursday, October 24th, 2024. I appreciate that it bolded it for me as well, just to be like, no, I mean it this time. I'm not sure how I got that so wrong in my previous message. These things are nuts, aren't they? So cool. What we have now is an agent that we can chat with, but still has no concept of the outside world. It's got memory, but it still has no tools. It has no ability to really know what's going on. And so we need to define some tools for this. I like to show off kind of defining tools with the easiest possible thing I can think of that actually would be useful to an agent, adding numbers together. It's important to note that language models are, they are coming up with a probability of what the next text tokens are to come out of things. And so anytime you ask them a maths question, they are guessing. And so giving it a calculator is genuinely a useful thing. And so if we give it an add function like this, we can help it correctly add things together. But it's also really simple. There's some differences about how this is defined as to whether you, compared to how you might normally define an addition function. So in this case, we've given it an option, an object of options in the parameter. So it's got a single parameter that has option. It is a single parameter with properties on it. And then we're returning not just the number, but like an object that says, this is the result of the addition. And that kind of helps the model's response. If it gets a whole bunch of numbers back because it did a bunch of different things, this is the result of adding some numbers. But the actual code to do the adding, that's easy. Defining that tool for the model is the more important part. Because what you need to do is declare your tools and describe them to the agent so that it knows when to choose to use them. And so in this case, all tool functions have a name, and this one's called add. They have a description, which helps the agent understand when to use it. And then it has a parameters object. You can have a tool that takes no parameters. So we'll actually see a date tool later, and there's no need to give it parameters to find out what the date is today. That's just the date today. But this addition function has parameters. It's basically JSON schema. Although it pretty much always starts with a base object. That's why I've not done two parameters, but an object with two properties. And then you can describe each of the parameters, and you describe the object. So in this particular case, we have A and B, and A is a number and B is a number, and that's it. For every single tool that we give to our agent, we do have to provide it with this entire object of descriptions of stuff. And that can eat into your context. That can actually take up a bunch of space. So we'll see what we do about that later. But then when we get to using it, this actually goes back to the original generate content function, because tool use can be done in a chat or in just a regular generate thing. And in this case, we provide it the declaration of the tool. We provide it how that tool works. And again, it's actually our job to call the function if the model wants to call it. And so in this case, if you called generate content and said, hey, add 2 and 3 together, and gave it a tool for adding things together, it's not going to return text to you. It's going to return function calls. It's going to say, hey, I want to call this function, and here are the parameters that I would like to call it with. And so actually, let's see that in action. Let's build that now. This is kind of the absolute core of our model, of our agent at this point. We're going to build the loop in which we give it some tools, and when it asks to use those tools, we call those tools, and we give the information back to it until it's done, until it has reached its goal. And so let's take our chat agent and copy it and make a new one. And this one I will call the agent because it's actually the only one that's really an agent at this point. And I'm going to add one thing to the constructor. We're going to pass in some functions. This stuff functions. Cool. And then the rest of it, go away. The rest of it happens here. So I'm going to change that from a const to a let, because I'm going to loop around and keep changing the response. I'll make that a bit smaller. I have no idea why VS Code wants to generate a mermaid diagram. That is wildly unuseful. So it's a big while loop, like I said. And we're going to say while the response, whilst it has function calls and there's more than one of them, we're going to go through. So the model can ask to call more than one function at a time. So this function calls could be is an array. It's normally just one thing, but it could be more. And so I'm going to get some function calls. Is going to be the result of a promise over all of the. I'm just going to stop Copilot for a minute because it is 100% getting in the way. Go away. Turn it off. Snooze. We're going to wait for a promise. These could be asynchronous calls, so I'm just going to wait for them all to happen. We're going to take the response.function calls and map over them, and for each of the calls, we're going to call on them. And with that, a function call comes with their name and some args. And that's all it is, right? It's just the name of the function it wants to call and the arguments it wants to call them with. And we're going to get that out of the call. And then the magic part is function response. The response is this.function's name. So we look into our object of functions that we've passed into our agent, and we call the function with the arguments it wants to do. That might be asynchronous, await. But that's about it. That's kind of the magic. We go and call the function with the arguments. There is no magic here. And with that, we're going to return a function response, which has the original name and the response. I don't think that's its name. Hold on. It is that. Yeah, cool. Right, so what we've done here is we've got this big loop over the function calls, and for each of those function calls, we call the function with the arguments. Once we've done that, we then make a new response. So we're going to call on the model again, this.chat.sendMessage. And this time, instead of the message being text, we're going to send in the function calls. The function calls? Yes. I'm doubting myself this morning. It's exactly that, yeah. But that actually needs to be an object. And that should be it. So if I swap out my chat agent for my agent over here, it's going to break. Yeah, OK, I was doing something wrong. Something's got to be asynchronous somewhere. It's there. There we go. Cool. And so I can say hello to it again, and we're back with the chat agent. We haven't given it any tools yet. We haven't actually given it anything to do. We've just built this loop, but it will never call on any of the functions because it doesn't have any available to it. So I'm not going to take you through too much building of tools. I'm just going to look and say, first up, I want it to get that date right. And so here's a date tool. Here's a declaration. And like I said, this one doesn't take any arguments, so it's just a name and a description. And then the function is just going to output the date to a string so it can read it. All of my tools from now on do include this little log to say, think, I'm doing this. This just shows you when they're using a tool, it's not really thinking. But if I go and import my date and date function declaration, from, oh, that's right, I turned off all the autocomplete from tools, date tool. I can then pass to my agent. I need some tool definitions. Ooh, not that. So the tool definitions is going to be my date function declaration. Date function declaration. And then to the agent, I'm also going to pass this object of the functions it's going to call. So again, this is all the kind of config that's going into the agent, and this is the config that's this is the config going into the model. Here's your tool definitions. This is the config of the functions that the agent object that we've created can call. And so now if I say, hey, what's the date today? It should think about it and get it wrong. Yeah, cool. I know why this is. It's just because I've tool declarations, not definitions. There we go. It's just me and spelling. So what's the date today? Undefined. Good job, lad. That's horrifying. Why would it do that to me? So what I'm going to do is not worry too much about that, because here's one I made earlier. What did I do? Nothing different. Let's try one more time. What's the date today? Getting current date. It's Thursday, June 4th, 2026. Hooray. So it's now in chat. No, now it knows. And it can find stuff out. Are you sure it's not May 2024? It might think about it again, actually. Really sure. I understand why you might be surprised. But it really is June 4th. Good. And again, it bolded it to be very certain about the whole thing. Great. So now we have an agent that has memory, at least short-term memory of its conversation, and the ability to call on tools. And all we really did to achieve that was build this this loop here, which is no longer than 12 lines of code. And that's kind of it. The magic of agents in 12 lines of code. Obviously, the magic does really exist inside the model, which is capable of providing these tool calls for us, but everything else can sort of be handled with just this. And so we can create all sorts of tools that we want to right now. We can go write all of these ourselves. So we've got this date. We could do retrieval augmented generation. As I said earlier, that's what I'm working on with OpenRag as a thing. We can have it fetch web content. We can have it call APIs. We can have it call other agents. Like an agent can just be a tool to another agent. And if they have different tool sets, they have different capabilities, they have different instructions, they can do different things. But really, they can just act as tools. But that's pretty boring. I don't really want to write all of those tools for myself. We can go further than this. I'm going to assume at this point everyone's heard of MCP. Some nods. Yeah, good, because it's the Model Context Protocol. It is our it's a standardized protocol for agents to interact with services. I think it's important that it's a standard. Like this is what the industry is working together to ensure works across agents, across models. I gave a talk yesterday in room 4 talking about one of the extensions to the MCP protocol, which actually allows for generating and using interfaces within a chat. I'm not going to go that far today. I'm definitely sticking with my CLI version. But because we have this protocol, a standards body and a protocol around this, then we can build one MCP server that is capable of working across all models and all agents. And it is made up of sort of two halves. The server is the bit the people who want to build tools build. So we make available tools. Those are the function calls that we've been looking at. There's also resources, which are more static objects, context for the model. And then prompts, which are kind of suggestions from the MCP server to the agent for how it might talk to it, which I think is quite nice. And there's a fourth thing, which is sampling. An MCP server can actually say, hey, I need a completion. I need an AI completion for this. Can the model do that for me? And so there's sort of a back and forth between the server and the model. And then clients, which is actually what we're building in this talk, like interact with those servers on behalf of the agents. And so pretty much all clients today support MCP, aside from Gemini, straight up Gemini app, doesn't do MCP at all. Bizarre. Anti-gravity, Google's new coding agent one does, but Gemini on its own as an application doesn't do it. So let's add an MCP client to our agent. I have a bunch of MCP things already set up here because this is just going to get very repetitive. But the first one I've got is a file system. This one, file system, MCP server. This is actually built by the MCP project itself. And it's just running an npx command. So this is going to run on my local machine and access to the files and give access to the file system. So there's two transports, sort of three transports, two important transports for MCP. One is standard I/O, so we just kind of talk to it over a regular socket connection. And that's useful for anything that is running on your own server. The other one is now streamable HTTP, which is much better for remote MCP servers, which honestly I think is most of where the future is with these things, because every person running an agent also having to run a whole bunch of other processes on their machine is a nightmare, and really it would just be great to connect to a URL and have it work that way. But the transport is separate to how the whole thing works. And so in this case, our agent is just going to create ourselves a little client, connect to the transport, and then I've got a very Java-like function name here, which just takes the tool declarations from the MCP server and turns it into that shape that Gemini requires. Again, it's mostly sort of JSON. I've completely lost. JSON schema. There we go. It's mostly JSON schema. There's some slight tweaks to things for different models. But yeah, we just we take so from the server, you can tell it to list the tools, like what are the tools you have available, and in this case, we turn it into that JSON schema declaration. And then finally, also run through those tool declarations and create functions that are going to call them. And really, the function that calls it is just sending the arguments to the MCP server. The MCP server is doing all the calling for us now. So I'm just going to open up a couple of other ones there. I've got a calculator and an SSH, no, not SSH, a bash client. And so when we get out of there, we're going to be using bash client, calculator client, and file system. So in our agent, I'm now going to import a bunch of those things. And let's declare the MCP tool declarations. Yeah. And also the MCP tools. Nope. MCP tools. There we go. So I really like MCP because you no longer have to write the tools for yourself anymore. Other people can do it. And I like it when other people do writing the code for me. So that has loaded, and actually you can see like in the background, all those MCP tools have kind of started in the background. And so what I can do with it now is ask my agent to, hey, take a look at this project and describe it. And if I do that, it's going to start looking at the file system. And so it's looked at its current directory, and then it's starting to read the README and the package.json, and then all the agent files that we wrote. And yeah, it's just running through all of them. It's listing directories, reading text files, and has given me an answer. So normally it's quite pleasing about it. This project is a modular AI agent framework built with Node. It demonstrates how to build sophisticated agents. It's 12 lines of code in a loop. Come on. That's very nice, isn't it? But anyway, yeah, so it's capable of reading that and understanding that, which is kind of nice. But then I can also say, hey, look at the agent file and create a new file with a refactored version in it. So this hopefully will allow it to rewrite the agent that we've written and make it better. Woo, look at that. Haha. Did a bunch of stuff there, didn't you? So it's made itself a refactored agent, and what has it done? Key improvements: modular logic, it extracted the function call handling, robust error handling, because I didn't have time to write error handling, so it's done it for me. And also apparently readability, that's nice. JS.comments, so let's have a look at it. Go away. This is our new refactored agent, built by the agent itself. And yeah, it has written some comments for me, nice. And it's extracted the loop into a private function, like it said. And it's done some error handling, so there's some try catches. The real test of it is, if I replace agent with refactored agent, does it still work? Now, because I've reloaded it, it has lost all of its memory. But if I say hello, is it still going to work? Yeah, cool. So I'll ask what the date is. What is the date? So it's refactored itself, and it still works, which is genuinely wonderful. So in about 40 minutes, or 35 minutes at this point, we've built an entire coding agent that was capable of rewriting itself and making itself better with a 12-line while loop and some MCP tools. So that's kind of cool, I think. Yeah. MCP has had a bit of a bad reputation from some people because of a couple of things. One, everybody got excited about MCP servers and added all the MCP servers they could find to their agents. And other people building MCP servers got excited and added 120 tools into their server. And this caused agents to immediately use up a whole bunch of context. We saw in our tool declaration earlier that even to declare an addition function takes quite a lot of JSON in order to do so. And when you have a lot more explanation and a lot more tools, you end up using up half your available context and costing that much in input tokens every single time. So MCP got a bit of a bad reputation for this. I genuinely think it was just because people were too enthusiastic about it. But it did lead people to, it did lead Anthropic, funnily enough, who came up with MCP in the first place, to also come up with the idea of agent skills. Are you using agent skills here? Yes. OK. Fantastic. So you already know they are standardized. They are a standardized way, but they're not under kind of any foundation just yet. I think they're still kind of effectively invented and looked after by Anthropic, whereas MCP is now sort of more public. And yeah, if you've used skills, then you understand that you start with a skill markdown file, and you can give it more stuff than that, right? You can have scripts, further references, further files that things can look at, assets, which are templates or resources. That kind of maps pretty directly to the MCP resources thing there. But the idea here is that is progressive disclosure, right? A skill markdown file starts with that little bit of that little header that kind of is a name and description. We've seen this in MCP before. But instead of with MCP, which loads the name and description and then all the declarations of all of the tools it provides, when you're dealing with a skill like this, you only load that header to start with. And if the agent wants to know more, it asks to read the rest of the skill. And if that skill then says, OK, I've got more stuff inside the resources folder or inside the references folder, or I've got scripts that we can run, it can then only, after it's read the first bit of skill, can then go, I want more of it. And so I was going to add some skills to this agent as well. I wrote a very basic kind of skill interpreter for this, which goes through our skills directory and just reads all of the directories and then reads the skill.markdown file of each of those and extracts that front matter, that header, and makes it available as we get skills and the actual full-on contents of the skills. This is still provided as a tool, though. It's still a single tool that is capable of reading and understanding skills. So there's this activate skill declaration that I'm going to provide to it, which just says, hey, you've got a bunch of skills, let's use them. And then finally, this is just the activate skill thing. So if we import a bunch of that stuff, import skill declaration, and load skills and activate skill factory. The first thing I'll do here is to we're going to get gonna load the skills in. That returns more than just that. We return skills and skill contents. There we go. Skills and skill contents. There we go. And we're also then going to we kind of make a factory for the single tool that we're going to provide to it that understands all of the things. So again, there we're going to use activate skill factory with the contents. Yeah. There, 1 second. That's right. So we get the activate skill. That's what we're doing. The activate skill is a single tool that knows about all of the other skills. And so with that, we are going to add our skill declaration to our tool declarations. We're going to add our activate skill tool to our agent. And we need to do one more thing, because at this point, it just knows it has a tool that can activate skills. It doesn't know what the skills are. And so we need to give it a system instruction, which currently is just you are a helpful agent. You have access to a number of skills. You actually don't need to see me type the whole lot of this, so here's a bunch more text. And indeed, that comes in under config as well. Config, system instruction. So in this case now, we're describing the skills. We're stringifying out the number of skills that they have that has been discovered from the skill directory. And like, if you have used skills, you know that you just basically put them into a skill directory, and that's it. So we're just discovering from that skill directory, and then we provide that single activate skill tool in order to provide the name of the skill. So that's not running for some reason. Yeah, probably why. And so I've given it a single skill so far that says something out loud. I couldn't think of anything more important to say. So in this particular case, it's just instructions, right? It's instructions to say, hey, if you want to say something out loud, capitalize it. So if I say, if I tell it to say hello to NDC Copenhagen out loud, it should think about using its skill. There we go. Calling execute. No, it's doing that again. Stop that. So what's hilarious about that, I think that was me, is that it doesn't have its skill. What are you doing, crazy agent? Sorry, bear me 1 second. Say hello to NDC Copenhagen. Activating skill, there we go, cool. So it now thinks saying something out loud is capitalizing it and putting underscores underneath it. But the important thing, the interesting thing about skills became that these models are also very good at running CLI commands. And so you can provide a CLI, or you can either use existing CLIs, curl or other bash kind of tools, or provide your own one, but it makes the model very good at using them. In this particular case, I was just going to upgrade my skill rather than just capitalizing things. We can upgrade it to use the say bash command, and this hopefully will make noise if the sound is there. If I now tell it to, what are we going to say? Say this again. Say hello to NDC Copenhagen out loud. It now goes, cool, I'm going to execute the command say using bash. And yeah, we didn't see it. We didn't hear it. But effectively, like, they're really good at using command line tools for this kind of stuff. And so if you've given, I previously gave it an MCP tool that gave it a bash access to bash. And so with the skill tool and the bash tool, it is now capable of using an enormous amount of stuff. So yeah, I think MCP servers and skills have different reasons to exist. Skills are very good at that progressive disclosure of things and capabilities of sending you off to CLI and things like that. Whereas MCP servers are much more, I think they're more controllable and useful if you're building like an agent with a specific purpose. Like this kind of generic lifestyle agents or coding agents these days that I think are very good for skills. If you're doing any kind of thing with it, if you're using OpenClaw or something like that, it can be doing anything. I think skills allow it to not use up all of its context, but have a bunch of options. If you're building an agent that is intended to do a specific purpose within a business, I think MCP servers are particularly good for that because you can just define the tools and the things that it needs to use at the time. And so I think they're both reasons to exist, but it's useful to have access to both of them. So yeah, So in this time so far, we've built ourselves an agent that went from echoing back things to us to a full chat interface that has the capability of using tools, MCP servers, and skills. What else can we do? How do we go further? This is the bit where we're now inventing the future, which is kind of cool. Like nobody knew how to build one of these, particularly. I think when Google put out that paper in 2024 that I've referenced for some definitions, like nobody had built an actual agent like this. And as we've seen, it doesn't actually take a lot of code to start. The rest of it is now up to us to build this future and to understand it better. Like even coding agents, 6 months ago, people were just sort of like on the fence about whether they're useful, and then 5 months ago, everything changed and everybody loves them. And the work that's being done into building agent harnesses in order to better guide the way they work and better guide how they use their tools and also protect against accidentally malicious behavior, that is the future for it now. And so I think people have said that like 2025 was sort of the year of agents, but 2026 is the year of agent harnesses. The models are very good. What we have to do is now build the other side of it that keeps that model in check, but also helps it achieve the goals that we want from it. And whilst I think there's a bunch of these generic kind of agents out there, OpenClaw, even things like OpenAI's Codex, which is kind of it escapes just writing code and is now a computer-using lifestyle kind of agent. Those are kind of pushing the boundaries, but it doesn't take that much to catch up to them and then try new things. And so this is the bit where it's absolutely kind of our turn to work with this. Build agents that we want to see in the world, build ones that are going to help our own work, our own businesses, and build the tools, build the MCP servers, build the rest of the kind of framework around it that makes things better. As I said, like over the weekend, I built myself an email inbox that never lets it send by itself. Actually, it does have a checkbox YOLO mode where I'll allow it to do things, but for the most part, it's that how much control we give the agent and how much control we like to keep in our own hands is the line that we now kind of have to walk as we're building these. And so I'm genuinely kind of excited as to what we can build for the rest of 2026 and where the rest of this goes in the future. It's almost impossible to predict any of this right now, whether there'll be step changes, further massive step changes in the models, or whether there's just a long grind of increasingly better agent harnesses that we create. The future kind of is with us, and I'm very excited about it. As I said, I work on a bunch of these tools around agents at IBM. These are all open source tools, which I encourage you to go check out. The thing on the left there is Langflow. Langflow is an open source drag and drop builder for agents, so it has a sort of a basic agent component as part of it, but allows you to kind of build up a harness around it just using drag and drop components. Docling, like I said, is a brilliant thing for ingesting all kinds of documents, but mostly PDFs because they're horrible. And an OpenRAG is a open stack for a RAG application that is customizable for your data and your users. Comes with its own MCP server, of course, as does Docling. Langflow itself can be an MCP server. All of these things could be of use to you if you're building these as well. I also publish a newsletter on building things in AI once every 2 weeks, so it's not too busy, but it does try and keep up with all the news about how to build agents, how to build what's going on with MCP skills, MCP servers and skills, and I would love if you signed up to that. I also promise you that I do actually write all of it. I don't just put it through an agent. It's curated by myself, so I'd love if you signed up for that. That should take you to the Langflow website to sign in. And yeah, other than that, again, my name is Nash. I'm a developer relations engineer at IBM. I absolutely love that we are building this future right now, and I can't wait to see what you build as well. Thank you very much. I think we do have 10 minutes if anybody has questions. Or you can just go get a coffee before anybody else gets out. I'm seeing no questions. Cool, go for it. And enjoy the rest of the conference. I'll be hanging around. Come find me out there if you want to chat. Thank you.